So guys, welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we have here these 10 questions to answer on the topic chemical equilibria. So guys, this video will be all about factors governing the equilibrium position. So in short, to stay till the end of this video. Also guys, I believe you already know that if you want to answer any question in this video, you can always pause this video and try out to see if you can answer the question even before we provide the answer thereafter. So let's quickly start with the first question here. It says, reversible reactions where forward reaction is endothermic when temperature of equilibrium increases. A. Equilibrium position shifts to right. B. Equilibrium position shifts up. C. Equilibrium does not position shifts to right. D. Equilibrium position shifts to left. So guys, the answer to this question is option A here. Equilibrium position shifts to right. So guys, question number 2 here says, for reaction in equilibrium, the species involved in the equilibrium constant expression are A. Gaseous and dissolved species. B. Liquid and solid species. C. Gaseous and solid species. D. Solid and dissolved species. So guys, the answer to this question is option A, and that's gaseous and dissolved species. The chemical species that are involved in an equilibrium constant expression are the gaseous and the dissolved species, not solid. So let's consider the next question here, guys. That's question number 3. It says, what role does the finely divided ion play in the Haber process of manufacturing ammonia? So guys, we have options A here, dehydrating agent, B, catalyzing agent, C, oxidizing agent, D, reducing agent. So guys, the answer to this question is option B, and that's catalyzing agent. In the Haber process of manufacturing ammonia, the finely divided ion acts as a catalyst. So it helps to increase the rate of the chemical reaction without itself undergoing the reaction. So that's the answer to this question. Let's consider the next question, guys. Question number 4. We have here, in the reaction M plus N to yield B, delta H is equal to plus Q kilojoules. So which of the following would increase the concentration of the product? A. Decreasing the temperature. B. Adding suitable catalyst. C. Increasing the temperature. D. Increasing the concentration of P. So guys, the answer to this question is option C, and that's increasing the temperature. If the temperature of this reaction is increased, then the concentration of the product will as well be increased, because an increase in temperature usually favors the side that is endothermic. So since the reaction above is endothermic, an increase in temperature will favor the forward reaction. Hence, there will be more of P produced, and that's the product. So let's consider the next question. Question number 5. It says, the equilibrium constant Kp expression involves A. Gaseous species only. B. Solid, liquid, and gaseous species. C. Species in aqueous solution and gases only. D. Species in aqueous solution only. So guys, the answer to this question is option C. That's species in aqueous solution and gases only. So we realize that solids and liquid species in equilibrium mixture are assumed to be constant or unitary. So we do not really express such species in the equilibrium constant expression. So as such, the answer to this question will be species in aqueous solution and gases. So guys, let's consider the next question. Question number 6. It says, so we have an equation of a reaction here, and from the equation of the reaction, we have a question to answer here. It says, in the reaction above, the catalyst used is A. Iron, B. Nickel, C. Vanadium trioxide, and D. manganese 4 oxide. So guys, the answer to this question is option D, and that's manganese 4 oxide. So the reaction above is actually one of the ways oxygen can be produced in the laboratory. So it involves the thermal decomposition of potassium chlorate to release all its oxygen when heated above its melting point. That's at 368 degrees Celsius. So this reaction actually requires the presence of manganese 4 oxide as a catalyst. So that's it about this question. So let's consider the next question. Question number 7. It says, when at equilibrium, which of the following reactions below will shift to the right if the pressure is increased and the temperature is kept constant? A, we have 2H2 gas plus O2 gas to yield H2O. B, 2SO3 gas to yield 2SO2 plus O2, all gases. C, 2NO gas to yield N2 gas plus O2 gas. D, 2CO2 gas to yield 2CO gas plus O2 gas. So guys, the answer to this question will be option A. And that's because with an increase in pressure, the side of the reaction with lower number of gaseous molecule is favored. So we have here 2H2 gas, that's 2 molecules of H2 plus 1 molecule of O2, that's 3 molecules to yield 2 molecules of water. So guys, this is the reaction that will shift to the right because the side with the lower molecules, which is the water, will be favored. So that's it about that question. Let's consider the next question. And that's question number 8. So we have an equation of a reaction here, and the question here says, in the reaction above, what is the effect of precipitating copper ion in aqueous solution as copper sulfide aqueous solution? A, there will be no effect. B, more ammonia gas will be generated. C, the equilibrium will shift to the right. D, ammonia gas concentration will decrease. So guys, the effect of precipitating copper ion in aqueous solution as copper sulfide in aqueous solution is that more of the ammonia gas will be generated, and that's option B here. So that's it for that question. Let's consider the next question. And that's question number 9. It says, if an equilibrium reaction has delta H that's less than 0, the reaction will proceed favorably in the forward reaction at A, all pressures, B, all temperatures, C, low temperatures, D, high temperatures. So guys, the answer to this question will be option C, and that's at low temperatures. So let's consider the next and the last question, guys. That's question number 10. It says, in the reaction above, a decrease in pressure will A, decelerate the reaction, B, increase the yield of phosphorus pentachloride, C, increase the yield of phosphorus trichloride, D, accelerate the reaction. So guys, we already know that a decrease in pressure will favor the side with the greater number of molecules, and an increase in pressure will favor the side with less number of molecules, gaseous molecules. So guys, from the equation of the reaction, decreasing pressure will cause this side with higher number of molecules, which is where you have the phosphorus trichloride to be formed. So hence, more of the phosphorus trichloride will be formed. So that's it for that question, and that's option C. So guys, this will be the end of this video. Thank you for watching this video. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally guys, we want to also encourage you to join our YouTube channel membership by clicking on the join button down below here, in order to become a member of our channel community, where you can access premium information on JAMB updates that will help you even as you study and prepare for your JAMB examination. So thank you for watching this video, guys, and see you on the next one.